Now we are coming to the last part and the most interesting part of complex number, and that is polar form of the complex numbers. So here we give the heading polar or trigonometrical form of a complex number. Now we have seen that the geometrical form of the complex number z, in which it is represented by x comma y on the argand plane. Let's draw it first, x and y. If this is the point P, O, and this is the point P, which is x comma y, this is mod z and this is actually theta. So this is on the argand plane. We get that OP is equal to mod z, and also we get that argument z is equals to theta. Now we will use the geometrical form of the complex number to obtain its polar form. In the polar or the geometrical form, the complex number z is represented as r comma theta. What is r? R is actually the distance in this case, and what is theta? Theta is the argument of z, which we have learned previously. So this is the x-axis and this is the y-axis. So here we are about to find out the polar form. From the above figure, we can say that this one I am taking is it as P, and this point suppose I am taking it as M. So can you tell me what will be the value of OM? OM is equal to x. So x we can write it as mod z into cos theta. From the formula of cos theta, because cos theta is equal to, this is x. From the trigonometrical values, cos theta is equals to x divided by r. We can write we know that cos theta is equal to x divided by mod z. So x can be written as mod z into cos theta. Also, what about MP? MP is equals to y, that is equal to mod z into sin theta. So now if you put the values over here, what we will get? Z, suppose we know that the main form of complex number is z is equal to x plus of iy. Put the value over here, mod z cos theta plus I into mod z sin theta. Because also sin theta from the trigonometrical ratio, this is equal to y by mod z. This is y by mod z is sin theta, and cos theta is x by mod z. So if you take over here mod z common, this will come as cos theta plus I into sin theta. So what is mod z over here? Mod z over here we have taken it as r into cos theta plus I into sin theta, which is the polar form of the complex number. So it is represented as r comma theta, and what is the polar form? Z equals to r into cos theta plus of I sin theta. Now with the polar form, there is one more part of complex number, which is principal values of complex number. After that, we will move to the sums of this final part of the chapter. So I am rubbing this part, and here we come to the most interesting part of complex number. So I hope polar form is clear to you. It's z is equal to r into cos theta plus I sin theta, where theta is the argument and r is the distance from the origin to the point P, and z is the complex number. So now we will start with the finding out of the principal values. For finding out the principal values, there will be 4 cases. Case 1, case 2, case 3, I am not going to rub this, and case 4. That's why I have written all together. Now first, let us draw the axes. I am drawing it all together so that you can easily understand the difference between the four cases. This is the x and the y-axis. This is the x and the y-axis, x and the y-axis, x and the y-axis. Here we will talk about the first quadrant. Here we will talk about the first quadrant. Here we will talk about the second quadrant. Here we will talk about the third quadrant. And here we will talk about the fourth quadrant. So first let's move to the first quadrant where both the values are positive and positive. If you take this distance again as O and this distance as P, if you draw a line over here, this theta and this is y and this is x, because this point P is actually x comma y. This is, we are talking about first quadrant. The value of theta in this case is always positive, as because it's in accordance with the positive direction of x and y axis. Now when we are coming to the second quadrant, look, when we are coming to the second quadrant, this is y is positive and x is negative. We know that in second quadrant y positive and x negative. Now if you are drawing the line this way, this is the point O and this is the point P, and this point, if you are taking the point as x comma y, this point will be y, and if you take this angle as alpha, suppose, what about this angle theta? What about this angle theta? Theta will be, if this whole angle is pi, this much angle is alpha. What about the value of theta? Theta will be pi minus of alpha. So whatever will be the inclination in the if the complex number is situated in the second quadrant, whatever will be the value of the inclination, the corresponding value of theta will be 180 degree minus of this inclination. When we will do the sums, the concept will be clear to you. So this is the first quadrant. This is the second quadrant. Here we know x is greater than 0. Y is also greater than 0. Here we know x is less than 0. Y is greater than 0. Now coming to the third quadrant. This is the third quadrant. And in third quadrant we know this is x is negative and this is the y-axis, and here also we will find it as negative part. So here x will be less than 0, y will also be less than 0. So look now, this is the point O and this is the P point. If we are trying to draw the line over to here, what we will get, if this is the point, this is the line alpha. Look, in this case, this is the angle alpha. Now look over to one thing. This case is accordance to the second case. Why? Because both the cases are same. Look, here there is an inclination and none of the parts are positive. Neither x or y axis is in the are having the positive values. So if this is in the upper part, this part is in the lower part. Look, this condition is appearing on the upper part of the axis, and this condition is appearing on the lower part of the axis. So what about this much part? So if whatever the value of theta will be here, the same value of theta will be in the negative direction of this value. So what will be theta in this case? Theta will be equals to minus of pi minus of alpha. As because take into consideration this case and this case. What will you get? What will you get over here? What will you get? As because this case is in the negative quadrant to the second case, so here theta is pi minus alpha. So here it will be minus of pi minus of alpha. Coming to the fourth quadrant. In the last quadrant, we know x is greater than 0 and y is less than 0, because this is positive. So this will be negative and this will be positive. Again, if you are drawing the line this way, this is equals to p value and this is theta is equals to, Here look, fourth case is in accordance to the first case. It is in the positive part and this is in the negative part. So here if we find theta is equal to alpha, here we will get theta is equals to minus alpha. So according to the quadrants, we have to find out what will be the values. Here x is greater than 0, y is less than 0. Here x is less, y is also less. Now we will come to the sums, then you will understand the cases. Coming to the first sum, given that z is equal to minus 1 minus root 3I, you have to find out the polar form of this. You have to find out the polar form of this complex number. Now look over here, minus 1 minus root 3I. If you find out the point, this will be minus 1 comma minus root 3. So minus 1 and minus root 3 both are negative. So which quadrant will it be? Obviously this will be coming in the third quadrant because both are negative in this case. So what will be the value of alpha? Alpha will be tan inverse of minus root 3 by minus 1. That is equal to tan inverse of root 3. That is equals to pi by 3. This is coming pi by 3 because root 3 means tan 60 degree. Tan inverse tan 60 is pi by 3. Now what will be theta in the third case? As because it's in the third quadrant, so we have to follow the third case. What will be the value of theta in this case? Theta is equals to minus of pi minus of alpha. So minus of pi minus of alpha means alpha minus of pi. What is alpha? Pi by 3 minus pi, that is equal to pi minus, this is equal to minus 2 pi by 3. So we have got the value of alpha, we have got the value of theta as well. And also what is r? R is equal to mod z, that is equal to under root minus 1 whole square plus of minus root 3 whole square. So what we will get this? This will be equal to under root of 4, that is equals to 2. So therefore the polar form will be z is equal to r into cos theta plus I into sin theta. What is r over here? R we are getting it as 2. So 2 into cos theta is how much? Minus 2 pi by 3. So minus 2 pi by 3 plus I sin of minus 2 pi by 3, that is equal to 2 cos 2 pi by 3. Sine of minus theta is minus sin theta. So minus I sin of 2 pi by 3. This is your answer of polar form. So how we have done? First take out the point, that is P is minus 1 comma minus root 3. So then find out, so both the points are negative. So it's in the third quadrant. So what about the value of alpha? Tan inverse minus root 3 by minus 1, that is equal to tan inverse root 3, that is pi by 3. Because root 3 is tan 60. Tan inverse tan 60 is 60 degree. 60 degree is pi by 3. So theta is actually, it's in the third quadrant. So what is theta in this case? Minus of pi minus alpha. So minus of pi minus alpha, that is alpha minus pi. That is pi by 3 minus pi, that is 2 pi by 3. Now what is r? R is mod z under root real square plus imaginary part square. So minus 1 square plus of minus root 3 whole square, it's 2, it's coming. So what is the polar form? Z is equal to r into cos theta plus I sin theta. Put the values. Cos of minus theta is cos theta. Sin of minus theta is minus sin theta. So minus I sin 2 pi by 3. This is cos 2 pi by 3. Next sum we are doing, if z is equals to 1 plus of I is a complex number, find its polar form. From the sum itself you can understand z is equal to 1 plus I. So the point is 1, 1. So it is in the first quadrant. It is in the first quadrant. So what is alpha? Alpha is equal to tan inverse 1 by 1. That is equal to tan inverse tan pi by 4. That is equals to pi by 4. So what will be theta in this case? In the first quadrant we have learned theta is equal to alpha only. That is pi by 4. What is modulus of z? That is equal to r, and that is equal to under root 1 square plus 1 square, real square plus imaginary part square, that is equals to 2. Therefore, what about the polar form? Polar form will be modulus r. Polar form will be z is equals to r into cos theta plus I into sin theta. So this is equals to 2 into cos of what is theta? Pi by 4 plus I sin pi by 4. So in this way, first we have to find out the point, then we have to check in which quadrant is it. If it's in the first quadrant, second quadrant, third and fourth quadrant, these all values of theta will be followed. Thereby, after finding out alpha, find out the value of theta and then find out z, which is the distance from the origin to that point. Then find the polar form r into cos theta plus I sin theta. Put the value of theta, put the value of z, you will get the polar form. Any questions of polar form can be found out using this rule. It's the easiest way. So here we come to the end of the chapter. If you have any doubt regarding any part of the chapter, feel free to write me in the comment section. I'll surely get back to you. Thank you. Have a nice day.